Part 2 of Lesson 5, Chapter 4 is going to be on graphing a secant and a cosecant graph. Part 1, we discussed graphing a tangent and a cotangent graph with transformations. So let's just review that for a second. You got a tangent graph that looks like this. Asymptotes are at the half pies. It's an increasing function. Cotangent function is a decreasing function. Asymptotes are at the pies. Both the tangent and the cotangent have a period of pi. And so a cosecant graph looks like this graph on the left, and you can see it's a U-shaped parabola curves in between asymptotes. Some U-shaped curves are going up and some are going down. And then a secant graph is like this graph over here on the right, which is also U-shaped parabola curves in between asymptotes. Some are going up, some are going down. So you can see why we're grouping these two trig functions together, because they look very similar. There are some differences, though. The cosecant graph on the left has asymptotes at the pies, and the secant graph has asymptotes at the half pies. Otherwise, they look very, very similar. The period on both of these is 2 pi. So you can see that the asymptotes are separated by a distance of pi. However, a period is 2 pi. So one cycle is a U-shaped curve going up and a U-shaped curve going down. So let's talk about graphing just a basic cosecant function. So basic cosecant function, if I was going to graph that, I'd first want to graph its reciprocal, which is a sine wave. If I'm going to graph a sine wave, I would set up my x and y axis this way, and I would graph a sine wave. So a sine wave graph looks like this. And how that helps me graph a cosecant is wherever the sine wave touches the x-axis is where we're going to have vertical asymptotes. So you can see where that sine wave crosses the x-axis, I'm putting in my red vertical asymptotes. And those are always spaced equally apart. In this particular case, it's 2 boxes apart. And now we draw the U-shaped parabola curves. You can see where the sine wave hits its high point, we draw a U-shaped curve going up. And where the sine wave hits its low point, we draw a U-shaped curve going down. So that's one cycle of a cosecant graph. If we wanted to draw a graph of a secant graph, we would first draw its reciprocal. Now its reciprocal is a cosine graph. So let me draw a picture of a cosine wave. Set up my x and my y axis this way. And so drawing a cosine wave would look like this. So there's a cosine wave, and wherever that crosses the x-axis is where we have asymptotes. You can see that this is at the half pies. And your asymptotes are always equally spaced apart. And then wherever the cosine wave hits a high point, we draw a U-shaped curve going up. And wherever the cosine wave is hitting a low point, we draw the U-shaped curve going down. There's one cycle or one period of a secant graph. So those are just basic cosecant and secant graphs. And here's a picture on the left of a cosecant graphed at the same time with a sine wave. You can see the sine wave is the blue dashed line. And you get your vertical asymptotes at the pies. And then you can see the U-shaped curves going up and down. The graph on the right is a picture of a secant graph. And you can see there's a cosine graph. It's the blue dashed line. And where that crosses the x-axis, you get your vertical asymptotes, which are at the half pies. And so there's an example of a secant and a cosecant. So let's do a couple of examples. This first one is a cosecant graph that's been shifted to the left pi over 2. Well, the normal asymptotes for a cosecant graph are at the pies, but we got to shift everything to the left half a pi. So instead of there being an asymptote at 0, we have one at negative half pi. Instead of pi, it's positive half pi. And instead of 2 pi, it's 3 pi over 2. So if that's where the asymptotes are going to be located, what we'll do is we'll set up the x-axis to make it easy to draw those asymptotes. So what I would do is make this half a pi. And now I can put those asymptotes in at negative 1/2 pi, positive half pi, 1 1/2 pi. And so So now, if I'm going to draw this, I would like to draw the reciprocal of a cosecant, which is a sine wave, in this case shifted to the left, pi over 2. So if I'm going to draw that, normally I start at 0, 0, but I'm going to start it over here, shifted to the left. And there's a sine wave that has a period of 2 pi, shifted to the left, pi over 2. That makes it easy to know where you're drawing the U-shaped curves going up and where you're drawing the U-shaped curves going down. Next one is a secant graph. Now, a secant graph normally has asymptotes at the half pies. But we've got a horizontal stretch or expansion by a factor of 4 because it says secant of x divided by 4. The b value is 1/4. So if I multiply each of these asymptotes by 4, it's going to give me 2 pi, 6 pi, 10 pi. So that's where our asymptotes will be located. And then if I'm going to draw a graph, putting those asymptotes in those locations, it probably makes sense to just go by pies, because that should make it easy to put these asymptotes in. Vertical scale is still 1s. So we've got one at 2 pi and at 6 pi. These are 4 boxes apart. So if I go backwards 4 boxes, we'd also have one at negative 2 pi. And then anytime I draw a secant function, I first draw its reciprocal, which is a cosine. In this case, cosine of x divided by 4. So if I draw a cosine wave that has a period of 8 pi, that would be like right over here. Here's a cosine wave that has a period of 8 pi. And that makes it easy to know where you draw the U-shaped curves going up and where you draw the U-shaped curves going down. So there are 2 examples. Let's do 2 more. The next one I have is a cosecant of 2 pi. Normal asymptotes for a cosecant are at the pies, but we've got a horizontal shrink of 1/2, so I have to multiply each of these by 1/2, and you can see that the asymptotes are no longer going to be pi units apart, they're going to be half pi units apart. So setting up my x-axis, that should make it easy to plot my asymptotes. And so we got one at 0, half a pi, 1 pi. You can see every 2 boxes we have an asymptote. Now, anytime I graph a cosecant function, I first graph its reciprocal, which is a sine of 2x in this case. So I'm going to draw a sine wave that has a period of pi, which is how I get these points, and I get a graph that looks like this. That's a sine wave with a period of pi. Thus, I'll draw my U-shaped parabola curves going up right here and down right here. This is one cycle of a cosecant of 2x. Let me draw in a second cycle. And now I've got 2 periods drawn. I always try to draw at least 1 period. No more than 2 is really necessary. And there's the graph of a cosecant of 2x. Last example, here's a secant graph that's being shifted to the left pi. Normal asymptotes for a secant function are at the half pies. But everything's being shifted to the left pi. So that's not going to change where we have asymptotes. We're going to have asymptotes in the same place, but it is going to change where we have the U-shaped parabola curves. So that's where the asymptotes are going to be. So let's set up the x-axis in such a way that makes it easy to show where those asymptotes are. All right, so we've got one at negative half pi, one at positive half pi, 3 pi over 2. These are 4 boxes apart. And so since we are drawing a secant graph, let's first draw its reciprocal, a cosine, shifted to the left pi. So a cosine wave shifted to the left pi. Let's see here, pi is going to be like over here, and then it's going to cross there. So there's a cosine wave that's been shifted to the left pi units. That makes it easy to know where to draw your U-shaped parabola curves. Okay, so this is day 2 of graphing other trig functions on lesson 4-5.